Good morning, students. In this video, I am going to introduce a new chapter of chemistry, that is chemical reaction and equation. This chapter I have selected from standard 10 class because board dates it has come out. And this chapter is the backbone of chemistry. If you see the syllabus of the chemistry of standard 10 CBSE board, then you find that there are 4 chapters that we need to study. First is the chemical reaction and equation. Second is the acid-base salt. Third is metals and non-metals, and fourth is carbon and its compound. There are 4 important chapters that you have to study, and questions will be asked from these 4 chapters in the board exam. And chemical reaction and equation, this chapter is very important for other 3 chapters. Because in this chapter we have to study what is chemical reaction, how you are going to represent chemical reaction in terms of equations, how will you balance the chemical reaction, then types of the chemical reaction, what type of chemical reaction you have to study, and their application. So once you have a command on this chapter, the other chapters will be easy for you. So first I will explain where or how these chapters are useful, how this chapter is useful for other concepts also. For example, metallurgy topic or metals and non-metals. In this chapter, we have to know chemical reaction of the metals. Chemical reaction of the metals. For example, magnesium reacts with oxygen to produce magnesium oxide. Magnesium reacts with oxygen to produce magnesium oxide. So here 2 parts are taken from this chapter. First is the formation of the formula and second is the balancing. So this part has been taken from chemical reaction and equation. Second thing, acid, base and salt. In this chapter, you have to know properties of acids. For example, acid react with metal to produce hydrogen gas and salt. So here the formation of this compound, this salt, is a part of chemical reaction and equation. You can take example of carbon and its compound. Over there you have to study about methane, you have to study about alcohol, aldehyde groups, and the reaction of methanes, reaction of hydrocarbons, CO2 plus H2O, its balancing. All these concepts have been taken from chemical reaction and equation. So that's why I have selected this chapter. In this chapter, first I will explain what is chemical reaction. Second thing, what is reactant and products. Next, chemical equation. Next, balanced chemical equation. Next, effect of chemical reaction. बहुत important, very important. ये part बहुत important है. Effect of chemical reaction. Next, types of reaction. In this part we have to study about combination reaction, decomposition reaction, displacement reaction, double displacement reaction, redox reaction, then effect of oxidation. There are two effects of oxidation. First is corrosion and second is rancidity. So these are the points that you have to study, that you questions may be asked from this part. So I will explain all this topic one by one. So the first point that we have to focus, what is chemical reaction? What do you understand, or how will you explain chemical reaction? You can say chemical reaction is a process in which new products are formed. And in this type of chemical reaction, or in the chemical reaction, old bonds are broken, new bonds are formed. For example, you can say hydrogen reacts with chlorine to produce hydrogen chlorides. So this is nature of hydrogen gas and chlorine gas is totally different from the nature of HCl. So you can say that this is a new product. Now here the bond present between bond present between Cl, and here bond present between H and Cl. So this bond H bond has been broken, this bond H and Cl has been broken, and new bond between H and Cl has been produced. So this is a type of chemical reaction. So you can say it is a chemical reaction is a process in which new products are formed. New substances, you can say new substances are produced. First point. Second point, old bonds are broken and new bonds are produced. So, to show the chemical reaction, we need two things. First is the reactant and second is the product. Here, hydrogen and chlorine are reactant, whereas hydrogen chlorides are product. One other example I am taking, CaCO3, calcium carbonates reacts to produce CaO plus CO2. Here I am writing the state of the reactant. Calcium carbonate present in the solid form, calcium oxide, that is quicklime, present in the solid form, and carbon dioxide present in the gaseous form. So I have written the state. This state is going to be very, very important. I will explain how. So here this is reactant and these are products. So you can say that substances used to start a chemical reaction are called reactant, and substances produced after the chemical reaction are products. You can say substances used to start a chemical reaction are reactants, whereas after chemical reaction new substances are produced that are called product. And presentation of reactant and products in the form of equation that I have written here, calcium carbonate is the equation, in the form of equation is known as chemical equation. So you can say chemical equation is the presentation of reactants and product in the form of equation. So this is the points. Now the question is, what is balanced chemical equation? When we are going to start properties of the chemical reaction, then equation must be balanced. If the reactions are not balanced, then we cannot apply different properties. So it must be balanced. So how will you define balanced chemical equation? You can say if total number of atoms of the reactants are equal to the total number of atoms of the product, the reaction is called balanced. For example, here if you see left hand side and right hand side, here you can say calcium is the 1, carbon is the 1, oxygen is the 3. In the right hand side, calcium is the 1, carbon is the 1, oxygen is the 3. So here you can say this is a balanced chemical equation. Here, left hand side, here LHS and RHS. Here left hand side hydrogen is 2, Cl is 2, here hydrogen is 1, Cl is 1. So this is not a balanced chemical equation, this is unbalanced and this is balanced. So unless we will balance this equation, we cannot start to study any properties. That is, for balancing, law of conservation is used. Law of conservation of mass is used. That is, total mass of reactant must be equal to total mass of the product. So here first 2 hydrogen, here we will write 2. Now it will be balanced here. 2 hydrogen, 2 chlorine. So this equation is balanced. So you can see that balancing is one of the most important aspects of chemical reaction. Unless the reaction is balanced, we cannot start to study properties of different chemical equations. After that, we have to know what are the effect of chemical reaction. Very important. Very important points. When a chemical reaction takes place, what are the effects we can observe? That is important to know. So the first effect of the chemical reaction is the change of state. Change of state. That means when we start a chemical reaction, state of the reactant or products may change. That means state means solid, liquid, gas. For example, if calcium carbonate is taken, it present in the solid state. And when we start the chemical reaction, we get calcium oxide, this is also solid, or carbon dioxide, this is a gas. So change of state takes place. Melting of the wax. When we melt wax, then it is in solid form. After melting, we will get water and plus CO2 gas. So here, this is in liquid state, this is the gas state. Second properties that we obtain during the second effect of chemical reaction is the change of temperature. When a chemical reaction occurs, the temperature of the substance also change, And change of temperature can be explained in two terms. First is called exothermic reaction and second is called endothermic reaction. Exothermic reactions are those reactions in which heat is evolved. So, after the chemical reaction, the substance becomes hot. Temperature of the substance is raised. Whereas endothermic reaction is that type of chemical reaction in which heat is absorbed. It means after the chemical reaction, substance becomes cold. Its temperature decreases. So there are a number of chemical reactions. For example, when zinc granules is reacted with acid, it produces bubbles of hydrogen gas. Bubbles of hydrogen gas and temperature of that substance also increased. You just balance it here. Temperature of the substance is also raised. Third important property, one more example you can take. Third important effect of chemical reaction is evolution of gas. Evolution of gas. That means whenever a chemical reaction occurs, gas must be evolved. The first example I have given, this is an example of both evolution of gas and increase of temperature of the reaction. So the first reaction is evolution of gas, that zinc granules react with hydrochloric acid to produce zinc chloride plus hydrogen bubbles of hydrogen gas, and in this case temperature increased and this gas evolved. So evolution of gas will be so like this. Second, when sodium carbonate is heated in presence of acid, or sodium carbonate is taken with an acid, then here another gas is evolved, that is carbon dioxide gas. Carbon dioxide gas is evolved. So these are the example evolution of gas. That is when the reaction occur. First is the change of state. Second is the change of temperature. Change of temperature either in term of exothermic or in term of endothermic. I will explain these examples separately. Then evolution of gas. Fourth property is the formation of precipitate. Formation of precipitate. When barium chloride is reacted with sulfuric acid, then it gives a white precipitate of barium sulfate. So precipitate formation is one of the important characteristics of chemical reaction. When potassium iodide treated with lead nitrate, then yellow precipitate of lead iodide. This is white PPT. PPT, precipitate in terms of PPT. This is yellow precipitate. Is produced. So this is the formation of precipitate formation. Another example you can take when silver sulfate is reacted with sodium chloride, then here also a white precipitate of silver chloride produced. So these are the example of chemical effect of chemical reaction. One more effect also we observe, that is change of color. Very, very important. Change of color. Potassium permanganate, that is KMnO4, is a purple color substance. KMnO4, potassium permanganate. And when citric acid or you can say lemon juice, is added in this mixture, it becomes colorless. It is a purple color. Second things, potassium dichromate. This is orange color in nature, and when sulfur dioxide is added, it turns to green color. So this is one of the most important information. So these are the important points that you have to keep it in mind when you are going to start this chapter, that when a chemical reaction occurs, what are the important effect of the chemical reaction? First is the change of color, second is the change of state, third is the change of temperature, fourth is the evolution of gas, and fifth is the formation of products. So these are the important information that is related with the chemical reaction. The next part that we have to discuss, types of chemical reaction. When we are going to start a chemical reaction, what are the different types of chemical reaction? For example, displacement reaction. This reaction going to be used in organic chemistry part. Redox reaction, that is going to be used in organic chemistry part. Then displacement, decomposition, double displacement, combination, these all reactions are going to be used in metals, non-metals chapters, and acid, base and salt. So once you understand this equation very well, this reaction very well, you can apply, you can use this in other chapter as a application. So the second part that we have to discuss, that is types of chemical reaction. So the first reaction that is going to be, that I am going to explain, is the combination reaction. Very, very important. Combination reaction is a type of chemical reaction in which two or more than two substances combine to give products. For example, calcium oxide reacts with carbon dioxide to produce a substance that is calcium carbonate. This is an example of combination reaction. Carbon burns with oxygen to give carbon dioxide. This is also example of combination reaction. Magnesium reacts with oxygen to produce magnesium oxide, is another examples of combination reaction. Decomposition of vegetable waste. Decomposition of vegetable waste is also an example of combination reaction. Oxidation of methane. Methane burns with air to give carbon dioxide and water. So oxidation of methane is also an example of combination reaction. So these all reactions, evolution of heat occur. So we can say that here oxygen is used, carbon dioxide is used. So here all evolution of gas is used. So you can say that combination reaction is a type of exothermic reaction. There is one question that is given in NCERT book, exercise book, that how can you say that respiration is an exothermic reaction? Respiration is a process in which glucose burns in presence of air to give carbon dioxide, water, and apart from that, about 36 ATP energy are produced. So, the food product that we take, that food products are used to get energy. So, we take food in the form of a starch. Carbohydrate we consume in the form of a starch. So, first that starch is broken into different parts, that is maltose, sucrose in the mouth, and after that in the small intestine it finally dissociates, digests in presence of enzyme amylase, then it gives glucose. Glucose is the digested product of the sugar. So after that glucose is used to give energy. That glucose is C6H12O6. It reacts with oxygen. Here oxygen is the burning. In all this example, burning is going on. It gives CO2 plus 6H2O, and ATP, energy is used in the form of ATP. Adenosine triphosphate, you will study in higher classes. What is ATP? You have to just know that energy is evolved, and that energy is used, that we use to perform different work. So these all are examples of combination reaction, and in the combination reaction what is happening? Two reactants combines to give single products or more than one product. Second point is it is an example of exothermic reaction. Second example is decomposition reaction. Decomposition reaction is that type of reaction in which a reactant breaks to give two or more than two products. Decomposition reaction is opposite to combination reaction. Here heat is evolved, here heat is absorbed. So first I will explain the differences between combination and decomposition, and after that I will explain all the examples that is used in NCERT to explain the process of decomposition reaction. So combination and decomposition both are opposite. Here reactants combine to give product. Here reactant dissociates to give, mind it, you can say two reactant or two or more reactants combine to give product. Here single reactant dissociate to give two or more product. There is a single examples I want to take, single equation, that calcium oxide, that is quicklime, react with oxygen, carbon dioxide to give calcium carbonate, and here calcium carbonate dissociates to give calcium oxide plus carbon dioxide. So both are opposite to each other. So the first point is, second point, third is exothermic in nature. Exothermic in nature, it means heat is evolved. Here this is endothermic in nature. Endothermic in nature means heat is absorbed. So these are the basic differences between combination and decomposition reaction. Now I will use different examples to show decomposition reaction. First is potassium chlorates break to give oxygen gas. Potassium chloride plus oxygen gas. Second, lead nitrate breaks to give second, you can take another example. Hydrated ferrous sulfate. This is green color substance. Here we use a single heat, green color substance or solid. When it is heated, then several crystal of water gets separated and becomes colorless. And this part is called anhydrous. Very, very important. Anhydrous. And this further break to give iron oxide, sulfur dioxide and sulfur trioxide. So here the first thing that we obtain, that is the color. First indication we observe that color, that green color substance changes to colorless. And second thing that we obtain here smell of burning sulfur. Smell of sulfur we get. This is due to formation of sulfur dioxide. So these are the examples of decomposition reaction. In this reaction, substance breaks to give different product. One thing here I want to say that this compound, you can say this is crystals of ferrous sulfate. Crystals of ferrous sulfate. This is called iron 2 sulfate. Very, very important point I am going to explain. Here iron valency is 2. Because if we see the crisscross, sulfate is SO4 2 minus. And there is no any information, so here it is supposed to be plus 2. This is the iron plus 3. Because if you see the crisscross, then this 3 belongs to iron and 2 belongs to oxygen. And when we do crisscross, then we get this formula, Fe2O3. So here iron 3 valency is going to be used. Here iron 2 valency is going to be used. So these are the example of decomposition reaction. In decomposition reaction, reactant breaks to give two or more than two product. And second information is that about decomposition reaction. Here it is endothermic in nature. Third important reaction that we have to discuss is the displacement reaction. Third one is the displacement reaction. In this reaction, first I will say, you can say that these two examples I have taken, and it is given in the book also. Here what is happening? Zinc is displacing copper from its compound. Copper is a blue color substance. This is blue. This is also blue. When we react zinc or iron with copper sulfate, then zinc sulfate formation takes place and the entire solution becomes colorless. So what is happening here? Zinc, it is more reactive in nature. It is above in the displacement series. Displacement series you will study in metallurgy chapters, metals and non-metals. This reaction is above in displacement series. That's why it displaces copper from its compound and zinc sulfate is produced. If we want to show this reaction like this, zinc sulfate plus copper, then this reaction will not be possible. Here, zinc is more reactive, copper is less reactive, so copper cannot displace zinc from its compound. So you can say that displacement reaction is that type of chemical reaction in which highly reactive metal displaces least reactive metal from its compound. Third important reaction that we have to discuss is double displacement reaction. One thing I am here missing, that is very important point, I forgot to explain, that decomposition reaction, here we are using heat. So decomposition reaction is that type of chemical reaction in which we use either heat or electricity or sunlight, very important point, to break the compound. Here potassium chloride is broken in presence of heat, so then heat is taken to break. This is called thermal decomposition, very important point. Water is broken down with the help of electricity, that is called electrolysis. It gives hydrogen plus oxygen gas. And the ratio is to 2 volume of hydrogen and 1 volume of oxygen. Here electricity is used to break this reaction, because in NCERT questions, in NCERT book, questions has been given that give an example of reaction, decomposition reaction, which can be possible with the help of heat, which can be possible with the electricity, which can be possible with the sunlight. You can take silver chloride. Silver chloride is a white substance, and when it is taken in presence of sunlight, then it turns to silver plus chlorine gas and its color changes to grey. This grey color formation shows that it is decomposed, silver chloride decomposed to give silver. So this is very important compound because this is used in black and white photography. Another example is silver bromide, AgBr. This is also a white substance. This also turns to grey color when it is heated in presence of, or it is taken in presence of sunlight. So decomposition reaction can be categorized into three parts: whether the process of decomposition takes place in presence of heat, or in presence of electricity, or in presence of sunlight. When electricity is used, electricity example is a electrolysis. Electrolysis I will discuss when I will teach metallurgy part, because application of dissociation decomposition reaction I will explain in this video. This is very important part in metals and non-metals. A large number of compounds, highly reactive metals like sodium, aluminium, magnesium, potassium, they are prepared by the process of electrolysis. And actually we use fused salt of the metal, highly reactive metal, and they are electrolyzed to give cation and anion at their respective electrode. For example, you take example of sodium chloride. When fused sodium chloride is electrolyzed, just I want to explain, for electrolysis what we use, we take an electrolytic vessel. This is an electrolytic vessel. And in this vessel we take two rod or two electrode. One is the negative rod and another is the positive rod. Negative rod is called cathode and positive rod is called anode. And we use electrolyte. NaCl is an electrolyte. Electrolytes we use those substances which gives ions either heating or dissolving in water. So here NaCl breaks when it is connected with a battery or shell. So when electricity is passed, this NaCl breaks to give Na plus ion and Cl minus ion. The Na plus ion will discharge at cathode and Cl minus ion will discharge at anode. Actually at cathode, Na plus takes one electron and turns to Na and discharge here. At anode, Cl minus ion, it loses two electron and this Cl turns to Cl2 gas and this discharge here. So this electron is being transferred here and that is taken by sodium. So you can say two electrons are lost. So sodium take two electrons and turns to sodium atom. So this is the part of electrolysis, or you can say this is part of decomposition reaction, and in this decomposition reaction what we have used? We have used electricity to perform this reaction. That's why it is called decomposition by using electricity. When heat is used, then we can thermal decomposition, and sunlight, this is examples. Next part that I have to discuss, that I have to explain, is double decomposition reaction. In double decomposition reaction, exchange of ion takes place between their respective compound. For example, silver nitrate react with sodium chloride to gives a white precipitate of silver chloride. plus sodium nitrate. This is white PPT. So actually what is happening here, silver nitrate present in form of Ag plus and NO3 minus, NaCl present in place of NaCl, Cl minus. So the exchange of ion takes place between their respective compounds and products are there. One most example, acid react with base to give salt and water. This is also an example of double displacement. HCl react with NaOH to give NaCl and plus water. So here H present, H plus and Cl minus, NaOH present, Na plus and OH minus. This is a type of neutralization reaction, but we can say it is double displacement reaction also, because here exchange of ion takes place and it gives Na plus and Cl minus. So this is an example of decomposition reaction where two salts are taken and exchange of ion takes place between two salts. Next, that is the oxidation and reduction. It is also called redox reaction. Very, very important. This reaction is going to be used in the chapter organic compounds. Oxidation reaction, very, very important reaction that we have to study, and many questions you get from this part. First, you have to know differences between oxidation and reduction. Oxidation and reduction. There are two concepts we are using to distinguish oxidation and reduction. First is on the basis of oxygen and hydrogen. Oxidation is a process in which addition of oxygen takes place or removal of hydrogen. Whereas here addition of hydrogen, removal of oxygen. Very, very important point. When copper metal is left in air for short period, then they will find that it turns a black color substance. It appears black due to formation of copper oxide. But when this copper oxide is reacted with zinc metal, then it again turns to its black color disappear. So in the first part, addition of oxygen takes place. So you can say that here oxidation of copper. Copper is oxidized to give copper oxide. Here oxygen is removed. So you can say that reduction of copper but oxidation of zinc. Zinc is oxidized. Very, very important points, that when oxygen is added in a compound, we can say oxidation, or when hydrogen is removed from a compound, it is also oxidation. When oxygen is removed from a compound, it is reduction, or when hydrogen is added in a compound, it is reduction. For example, you can take Another examples also you can take. It is given in NCERT book. We can use some examples of oxidation and reduction, very, very important points. Here, copper oxide plus hydrogen. This is copper plus H2. In this case, loss of oxygen, reduction. Addition of oxygen, oxidation. One more example you can take. Manganese oxide reacts with hydrochloric acid to give manganese chloride plus water plus chlorine gas. So here first you balance it. It is 4HCl, 2H2O. So here removal of hydrogen, that is oxidation. Removal of oxygen, that is reduction. So these all are examples of oxidation and reduction in terms of oxygen and hydrogen. One more concept I will explain, that is on the basis of electron loss and gain. Very, very important. Questions may be asked in CBSE, some questions, some difficult questions also used. So you have to ready for such type of difficult questions. That is on the basis of electron loss and gain. On the basis of loss of electron. So second is the on the basis of loss and gain of electron. So oxidation is a process in which loss of electron takes place. Whereas reduction is a process in which gain of electron takes place. Very, very important points. For example, sodium reacts with chlorine to give sodium chloride. Here, NaCl present in form of Na plus and Cl minus. Sodium turns to Na plus. There is a loss of electron, so it is oxidation. Cl turns to Cl minus. There is a gain of electron, that is called reduction. And as both the process of oxidation and reduction takes place simultaneously in an equation, that's why it is also called redox reaction. So you can say that redox reaction is a type of chemical reaction in which two reactants in which oxidation and reduction takes place simultaneously in a chemical equation. Here sodium is oxidized and chlorine is reduced. One more information we have to know from this concept, that is oxidizing agent and reducing agent. Oxidizing agents means, I am going to give just information that is very, very important information, that here sodium turns to Na plus, so sodium is oxidation and here it is reduction. So those which undergo the process of oxidation are reducing agent, whereas those which undergo the process of reduction, oxidizing agent. You can say reducing agent oxidize itself. reducing agent undergo the process of oxidation. They can lose electron. They can lose electron. Whereas reducing agent, oxidizing agent, they can reduce itself. That means they gain electron. This is very, very important. Oxidation means just opposite. Oxidation means reducing agent. Reduction means oxidizing agent. Oxidizing agent means have a tendency to lose electron. And here oxidizing agent means have a tendency to gain electron. Very, very important information, and questions may be asked from this part, that what is oxidizing agent and what is reducing agent. Don't be get confused that if oxidation, they are reducing agent. That's why all the metals are good reducing agent, because they have tendency to lose electron. Whereas all non-metals are good oxidizing agent, because they oxidize or they reduce itself. That means they have tendency to gain electron. Oxidation has two more application. Many application is there, but in your book 2 application has been given. First is the corrosion and second is the rancidity. Corrosion is a process in which materials are eaten up when exposed to air, water. It is also called rusting when we use iron. Iron reacts with air or moisture to give a product, that is corroded product, that is removed from its surface. Rancidity is the oxidation of fats or oil molecules that is present in the food. If food are exposed to air, moisture for a long period, they get oxidized, and due to oxidation, nature of the food will change. They will become poisonous for us, toxic for us. And the reason is oxidation. So if we want to avoid this oxidation, if we want to keep materials made up of oil or fat, we have to remove oxidation. So we are using a number of processes to avoid the process of oxidation. For example, the food, basically chips, it is covered with, or it is filled with nitrogen gas. Nitrogen gas avoid oxidation of the food material. Second thing, keeping in refrigerator is a good source that is used to avoid oxidation, because temperature of refrigerator is low, so the process of oxidation is slow. Third, airtight container. If we keep material in airtight container, then there will be no oxygen, so no oxidation. Fourth, keeping the things, food articles, away from sunlight. Sunlight is also a good source of oxidation. So these are the information that we used in chemical reaction and equation, and a number of questions has been given in this part, and that, for example, why should a magnesium ribbon be cleaned before burning in air? Magnesium is a highly reactive metal, so it reacts with air to give magnesium oxide. That's why we clean it before using, because when we clean, we remove magnesium oxide part. Second question is given, write the balanced equation for the following chemical equation. This equation I want to explain, because I have observed that students, basically CBSE students, have problem related with balancing part and equation part, because they start how to make formula in standard 9 only, and their application